So my name is Agata Goździk. I'm from the Institute of Geophysics, Polish Academy of Sciences. And today I will tell you a few stories about sea ice and why the sea ice is so important. So we will start with very simple question, I think. So what is sea ice? And write your definition in the worksheet, the task number 1. What is your definition of sea ice? You may also see that on the picture. This is taken in July 2011 in Svalbard. Svalbard is archipelago far north, belongs to Norwegian governance. And this is the view I had when I was traveling to Polish Polar Station. So take 1 minute to write your definition of sea ice. So this is what we have. So sea ice is frozen sea or ocean water. So it forms in the ocean and may grow or melt over seasons and years. So this is the definition. And why is it important? Mainly because it's very much connected with the global climate. It keeps all the polar regions cool because ice helps reflecting the sun radiation. So when the sunlight comes and hits the surface covered by ice or ice and snow preferably, then it reflects back a lot of sunlight. Whereas in the summer or when the sea ice melts a lot, then it exposes the dark ocean surface. And dark surfaces, you know it from your experience probably, if you wear a dark t-shirt, then it hits a lot. And the same happens with the ocean. If the ocean is not protected by sea ice, when it's only water, it warms up quickly and the Arctic temperatures rise further. Scientists observe that the Arctic warms at least twice as fast as the rest of the world, and in some regions like Svalbard mentioned previously, it's even more, even up to 6 times higher than for the rest of the world in the last 4 decades. We are observing and measuring air temperature in Svalbard in our station for the last 4 decades, 45 years exactly. And our scientists were comparing the increase of temperature in Svalbard with the rest of the world. So here in Svalbard, it's definitely alarming. How we can monitor sea ice? In previous times, it was quite difficult because it could be only reached in very few places where people were living or where vessels could go. But now, even the Arctic and the Antarctic are remote regions. We are able to observe sea ice extent thanks to the satellites. So these regular observations of sea ice, including extent, so the area covered by sea ice, but also thickness of sea ice, is possible thanks to satellite. And the first was launched in 1978, so almost 45 years already of these observations. And now a short animation to compare what is sea ice and what are icebergs. If you think about the ocean, you may think about Titanic, so the most known ship that, due to the catastrophe connected with icebergs, sank. So here you will see what are the differences and where both forms are formed and why are they are dangerous. Let's have a look.
A tidewater glacier is a glacier which is terminating in water. In all glaciers, the ice is flowing down towards the end under its own weight. This flow causes stress and strain that lead to cracks. When these are deep enough, a piece of ice breaks off the front of the glacier and falls into the sea. This piece is called iceberg, and we call the process calving. Icebergs come in all different shapes and sizes. The smallest of them are as big as a human or a small boat and can be found near small glaciers, for example here in a fjord in Spitsbergen. The largest of them can become as big as whole islands, like the B-15 iceberg that calved off an Antarctic ice shelf and was as big as Jamaica. Icebergs can be very dangerous to ships. A big iceberg, probably coming from a glacier in Greenland, was what sank Titanic in 1912. The sea ice is different from icebergs in almost all respects. It starts as small disks of ice on the surface of the ocean when the air temperature falls below zero. The freezing weather continues, and it does during the Arctic winter. The disks expand mostly horizontally to create flat pancakes of ice. These are moved by wind and sea currents, and a rigid continuous pack of ice is formed. In spring and summer, when temperature rises, a part of the sea ice melts. However, some of it around the North Pole survives until the next winter and becomes the multi-year ice. Sea ice is not as dangerous to ships as icebergs, mostly because it's easy to spot and avoid. However, scientists have used sea ice to travel around the Arctic. A ship can be stuck in the sea ice as it forms in winter, and then flow with it around the whole Arctic region, allowing for scientific measurements made in very different locations. Such ship is then released in summer when the sea ice melts and can easily return home. So, to sum up, icebergs are formed on glacier and fall into the sea, while the sea ice forms as small pieces in the ocean. Icebergs have many different shapes and sizes and slowly disintegrate with time, while sea ice is mostly flat and grows from small crystals to fields as big as a sea. Icebergs can sink ships, while sea ice can be used to carry ships around the Arctic.
Okay, so I hope you now know more about sea ice and iceberg and the differences. And you also heard about various shapes and sizes. And I encourage you, I will show you in a moment in the chat, if we want to check how the icebergs are floating on the surface, which way up, how they are becoming after calving from the glacier. Calving is a very funny word in Polish, it's cielenie, calving. So the moment where some blocks of ice are falling from the glacier front to the ocean or to the sea. So here is this link, and you may have a look and you may draw whatever shape you want to have and check how it will behave. So I'm trying here, but you may also decide to have a shape that you will drop from high and see how it stays on the surface. And you may also decide on having very strange shapes and see what happens. And now is the time for the task number 2. So why are icebergs dangerous for ships? And have a look here, because if we have a ship that goes from this direction, this lower part of this iceberg is not seen from the surface. So what can an observer standing on the ship see is this only this upper part here. But if the ship goes from this direction, it may track here in this part of the ocean. Of course, at the moment we have very, so it's not that dangerous thanks to all the tools that we have on the vessel. But in previous times, as for Titanic, that was the case and that was a threat. So take 1 minute to write 1 or 2 sentences. Why are icebergs dangerous for ships? I hope you enjoyed drawing. If not now, you may save the link and try it later, because it gives a lot of fun to draw your own shape and see how it floats. Now a few words about salinity. So you know that the sea water is salty, right? However, in the process of freezing, um, small droplets with salt forms, and the salt, it is called brine, so solanka in Polish. And these small droplets are escaping over time. So after a few years, usually sea ice is almost fresh. So no salt inside, and sometimes it is even used by expeditions to get drinking water out of it after melting. But of course, in the very beginning process of freezing, some drops of brine may be trapped there. So it's important, if we want to use this sea ice for getting fresh water, we need to get really the old, like 3 years old sea ice. And you also heard in the animation that some scientific expeditions are using sea ice to go around the Arctic, trapped in the ice, and do some measurements, because this sea ice during winter time is very stable. So they may, once trapped in such sea ice, scientists may go out from the vessel and take some measurements, take some probes from the ice, but also beneath the ice, to do some measurements in water. And I will show you a short video, a teaser from the expedition Mosaic. This was an expedition that ended like 2 years ago. A very big European project with many nationalities, many scientists working together on the vessel that was trapped in the ice and was traveling around the Arctic for more than a year. And here, how to a short teaser, as I mentioned. If you are interested in that, you may look for information on this Mosaic expedition and learn more. I was also mentioning about this multi-year ice, and it's changing a lot. If you compare how old was, how much we had the old ice, we called the ice sea ice old if it's 3 and more years. So you see here that in March 1985, we had a lot of this old ice. So it was staying over summertime without melting. Only some parts were melting. Here we had some melting, and then a new ice formed during winter next year. However, the situation changed a lot due to climate change, and a few years ago the situation was totally different. We had only very small patches of old ice and only very young ice in a Beaufort gyre. So let's see also a video and a scientist explaining this situation.
In 1978, satellites began continuously observing the polar regions, and the dynamic beauty of the Arctic sea ice was revealed. What we expect to be a solid mass of ice is actually in constant motion. As researchers continue to seek a deeper understanding of this region, new information about how sea ice changes is coming to light.
In this animation, we're taking Arctic sea ice into the third dimension. Here, we're looking at the ice age, which is an indicator of thickness. Generally, older ice is thicker ice.
That's the voice of Dr. Walt Meyer, senior research scientist at the National Snow and Ice Data Center.
What you see in this animation is the ice pulsing out and in with the seasons. In winter, the ice grows out and expands outward. In summer, it contracts inward as it melts. You see the whiter ice, which is the older ice, moving around the Arctic, being pushed around by winds and currents that move the ice. Over the years, the ice pulses around and moves around towards the top along the coast of Greenland. The older ice eventually moves out of the Arctic and into the North Atlantic, where it melts. The ice gets replenished within the Arctic because some of the ice survives each summer and grows older, and particularly in a region north of Alaska called the Beaufort Sea, where the ice spins around in a clockwise direction called the Beaufort Gyre. And that ice can keep spinning around oftentimes for several years and gradually getting older and thus getting thicker. Eventually, the ice will spin out of that gyre and go out through Fram Strait. In the past, we've always had enough ice growth and ice aging, enough ice surviving the summers to replenish the older ice that's lost. But in recent years, we've seen less replenishment. There's been more melt during the summer, so the ice that goes out through Fram Strait has not been compensated by the ice growth. In addition, especially in recent years, we've seen some pretty remarkable things in the Beaufort Sea, where that area that used to be a nursery for the development of the older ice allowed the young ice to age and mature. What we've seen instead is the ice is now more broken up, more scattered, and that's allowing the older ice to melt within the Beaufort Sea. So we're seeing the Beaufort Sea go from a nursery to a graveyard for older ice. As we get towards the more recent years, much of that oldest ice, the ice that's older than 5 years old in the bright white, has almost virtually disappeared from the Arctic Ocean. And the Arctic is now dominated by younger and thinner ice.
Okay, so we heard that in terms of ice, we are experiencing the situation when we've got younger and younger sea ice. So the old ice is disappearing and it covers very small patches of the Arctic, this way Canadian Arctic. But what happens in terms of the area cover of the sea ice? And here we have a nice animation comparing last 40 years. The difference is really big, 34%, so 2 million of square kilometers. So it's really a lot. And now we will focus for a moment on the sea ice extent. So how much is covered by sea ice? So I believe that if I ask you if the sea ice is changing, you would say, of course it is, due to seasons. So during summertime, we are expecting lower sea ice extent, and during wintertime, higher. But you also heard that it differs over seasons and over years. And this is what makes some problems for the climate, because, as I mentioned before, sea ice helps us to cool the whole polar regions, thanks to this albedo, reflectivity of sun radiation. And now it's your turn to decide, to give the date or at least a month. When do you expect the lowest extent of the sea ice? So which month of the year you think is the lowest extent? And of course, try to give explanation. So the area covered by ice varies from 6.3 in the warm periods up to 15.5 million of square kilometers on average. So during winter time, we had much more sea ice there. It's obvious, but let's try to think which month has the lowest extent and why. Okay, we have information here, August. You were very close because the correct answer is September, and this is why. Because the sea ice minimum occurs at the end of the melting season, this is obvious, but the end of the melting season is when the average daily temperature falls below 0 degrees. And this happens, as you see on the climate graph, from Longyearbyen, so this is Svalbard capital city, in mid-September. So basically in August, we still have much above 0, so it's around 5 degrees Celsius. And the moment when we get below 0 is the moment when the sea ice starts to grow, because previously it was only melting. The fastest melting rate was in July because it was the hottest month. The hottest is maybe not a good word because it's around 7, an average for the day, but still it was enough to melt the ice. Whereas in September, when we start with the temperature below 0, the sea ice extent is growing. Okay, but what are the differences? So how wrong is the situation, let's say? In 2012, mid-September, we had the lowest ice extent ever. And I will show you in a moment a graph, because it's thanks to these satellite observations, we had a very exact number of area covered by sea ice. Here you see that. So here this yellow or orange line is a median from observation time. So this is what is a normal situation, let's say, but the last years, due to climate change, we observed the shrinking of sea ice extent. And this was how it shrinked. And now it's your task to calculate the difference between the minimum sea ice extent in 2012, which was the world record minimum, and compare it to the extent we have from the observations of many years. And for a moment, I will switch to this chart Arctic, because now we may easily check each year. So here you have observations from 2022. So the current numbers are here. Last observations from 24th of October are recorded here. And you see that the minimum was not that bad comparing to what happened in 2012. So in 2012, we had around 3.4 million square kilometers as the minimum. Whereas your task in task number 4 is to calculate the difference comparing to the median, also for the same day. So it's 6.3. So in the table, please write in the first column 6.3. We do not need to have all the numbers after the points. I think 6.3 is enough for us. For the second column, you have here the number. Oh, we need 16. Yes. So 3.4. Then please calculate the difference and compare it to area of our country. I see that we have another school with us at the moment. I do not know where are you from, but then we may compare the areas of the country. And let me know once you are ready and write your answer on chat. We have another school from Poland, I see. So the results should be the same. And remember that the numbers in the chart were in millions of square kilometers, and area of Poland is thousands of square kilometers. So you need to take it into account when calculating. Okay, around 9 times. Yes, that's correct. Thank you very much. So we lost in 1 year almost 10 times the area of our country. So it's really a lot. And what are the consequences? Because we are not using this sea ice in any particular economic reason, but the difference is in terms of physics and the climate. So if you look at this picture, you see very dark water and light patches of ice here. And maybe you haven't heard about albedo, but to make an easy explanation is albedo informs how much sun is reflected back from the surface. And the more sunlight is reflected, then the surface doesn't warm that quickly. So it may range from 0 to 1. And I believe that you know it from your experience. If you wear a dark t-shirt during hot day in summer, then you really feel that it's warming up quickly. If you have a white t-shirt, then it stays not that hot for longer. So if we compare asphalt, for instance, which is dark, to fresh snow, you will easily say that asphalt is warming quickly, is absorbing a lot of sun reflection, whereas the snow is reflecting back. Here is this comparison. So in open ocean, we are absorbing most, around 90% of the sun light, whereas for the ice, especially with snow on the surface, 90% is reflected back. So only 10% is absorbed. So now, knowing that, try to think about the consequences. So what happens if we have less ice, how it affects albedo, and how it affects temperature. And I will also give you a moment to use the words above the text to choose which is correct, and in a moment I will show you the correct answers. So I has, probably here we will use lower or higher albedo than water. And once we choose it, it means that ice reflects more or less sun radiation than water. When sea ice melts more than usually, there is more open water and more or less sun radiation is absorbed. and it's up to you to decide more or less. The temperature of the ocean increases or decreases. And it accelerates or it slows down melting of ice. So how it affects, again, melting of ice. And therefore we call it a negative or positive feedback loop. Let me know once you are ready and I will show the correct answers. Okay, so I will show you the correct answers. And this process, when one process accelerates the other one, is called a positive feedback loops. So it makes the whole system to be accelerated. So this is the problem for the climate regions, because the changes are accelerating. So if you are living now, thank you very much for today. And last two tasks are in fact a summary. So it could be done as a homework, for instance, or during the next lesson as a summary of what you learned today.